Number 3, an article claimed that only 38% of hotel visitors use the alarm clock provided. The manager wanted to see whether that proportion applied to the hotel where she worked, so she took a random sample of 700 of the approximately 10,000 visitors to the hotel one month. They checked whether they used their room alarm clock. Of the sampled visitors, only 35% used the alarm clock. So assume that the claim is true. The 0.38 is the true proportion. So I'm just going to jot myself a note. P then is 0.38. What is the approximate probability that less than 35% of the sample used the alarm clock? So I'm finding the probability that my sample proportion is less than 0.35. Before I do that, since I'm talking about the probability of a proportion, I need to think about the average of my sampling distribution of sample proportions. So the rule is it's equal to the population proportion, so I get a point for just pointing out it's 0.38. Then I get a point for checking my 10% condition. My sample size, 700, is in fact less than 10% my population size, and they actually tell us the population size. It's about 10,000 visitors. So because this is a true statement, my sample size is small enough, we can go ahead and accurately calculate my standard deviation of the sampling distribution of sample proportions. So it is the square root of the probability of success, so proportion, that's what I should say, population proportion, times the population proportion of failure, 1 minus p, all divided by your sample size, which again was 700. So I'm getting about 0.108 for that. So 3 points worth of work right there. Now I would like to put this on a normal distribution. I don't know it's normal, and if you don't write down why it's normal, you don't get all your points. When I talk about the sampling distribution of sample proportions, we need to check our large counts condition. So the count number of successes from this sample of 700 is more than 10. The counted number of failures will also be more than 10. Therefore, the sampling distribution of sample proportions is approximately normal. Which means I can draw myself a normal distribution to use. So I'm going to attempt to make that bell curve. In the middle, I'll throw the mean. I'll put my population proportion. Typical distance from p hat, from any p hat that is, to that population parameter is about 0.018, we said. And again, these are p hat values. So these are the proportion who use the alarm clock. We are interested in the probability of getting one of these proportions that ends up being, what was it, less than 35. That's several standard deviations below. So here's 35%, and I am looking for the probability of being in this space. So there's this tiny little tail. So I'm going to note the probability of getting a p-hat value that's less than 35% can be calculated using normal CDF, and I've already written out why I can use normal CDF. And I've shaded to show that I'm going to never stop shading on the left, but at the upper end of things I'll stop at 0.35. That normal distribution has an average of 0.38 and a standard deviation of 0.018, which turns out to be statistically small. Not the smallest probability we've ever gotten, but it's small enough that we should be hesitant. So is there evidence to doubt the article's claim of the population proportion? Yeah. This should only happen, assuming that the center is at 0.38, our results should only happen 4.8%. So a sample size 700 is unlikely then to have a proportion of 35% who use the alarm clock. Because this is unlikely to occur by chance alone, it's much more likely that just that center value was wrong in the first place. We have reason to doubt 0.3. It's probably